Hello all, I'm happy to welcome you all back to this lecture series, and in today's lecture we are going to see about the basics of evaporation operation. So basically, what is evaporation? It is one of the heat transfer operation where the heat that is being sent to any solution is actually utilized to remove the excess solvent from the solution. For example, imagine I have a very weak liquor or a dilute solution, and my aim is to convert it into a concentrated solution or a liquor. So basically it is going to have a solute and a solvent. Put together we have a solution, right? And as we all know, water is a universal solvent, and my aim would be to remove this excess solvent. So what I do is I supply some amount of heat to this solution to remove this excess solvent from the solution. So what happens? Any weak liquid that I have will be converted into a concentrated liquor. So this is the basic principle behind this evaporation operation. So it is important to note that the solute whatever I have or use in this process of evaporation should be non-volatile, because there is no point in having a volatile solute and also a volatile solvent. So anyone is going to get evaporator, and if both gets evaporator, there is no point in going for this operation. So it is important to know that whenever a particular solution is considered for the process of evaporation, it should be noted that the solute should be non-volatile, whereas the solvent should be a volatile one. And in most cases, the universal solvent water is being used. And if we look into the heat source that is normally used for this evaporation process, it is either steam or solar energy, fuel gases, oil, flue gases can also be used for this process of evaporation. So next we are going to see about the heat that is being sent to the evaporator, how it is being used. The first step is to increase the temperature of the solution near to its boiling point. So normally we know that when the phase change will be happening for a solvent. For example, let us consider water. We have water at 1 atm pressure. Okay, so we know that the boiling point of water is 100 degrees Celsius at 1 atm, and I have a solution. Imagine I have a brine solution and it is very dilute. I want to make it as a thick concentrated liquor. So in this case what I'll do, I'll just heat it. I know that the boiling point of water is 100 degrees Celsius at 1 atm, but the thing is, when I consider the same for a solution, its boiling point is obviously going to vary, because only the boiling point of pure water is 100 degrees Celsius at 1 atm. But for a solution, it is obviously going to vary. So the heat that I supply is mainly used to increase the temperature of the solution near to its boiling point. So that is the first use of this heat. When we look into the second one, to supply the latent heat of vaporization, because we want the solvent to get converted into vapor by losing all its the liquid has to be converted into vapor. So the steam or the heat source that we use, it gets converted into two steps. The first step is to increase the temperature of the solvent near to its boiling point, and the second step is to undergo some phase change basically. Next, so let us have a comparison between evaporation and drying. So why only evaporation and drying? For example, I could also go for the difference between evaporation and heat exchanging, or absorption and evaporation, or distillation and evaporation. There can be a number of combinations. But why evaporation and drying? Is basically because both evaporation and drying involves both heat and mass transfer. Hope you might also know the basics of mass transfer. So both of this operation involves both heat and mass transfer. But very importantly, evaporation comes into heat transfer side and drying comes into mass transfer side. So I think it's very important to have a good comparison between these two concepts. So first, like as I discussed before, evaporation is a concept where we involve in using a heat source to remove the excess solvent from any solution so that we get some concentrated liquor, right? On the other hand, drying is a process where we usually try to remove excess amount of moisture from any solid material. Basically, drying is for any solid material. And when we look into this evaporation process, it normally happens at a temperature near to the boiling point of the solution, because the water has to be converted into vapor. So whatever the solvent it is, like water or any organic solvent, it has to be converted into vapor. So the process has to happen near its boiling point. On the other hand, it is not like that for a drying. There is no point of drying boiling point. It just happens at the thermal means. And heat transfer, as I said, evaporation basically falls into the heat transfer operation, whereas drying falls into the mass transfer operation. If we remove it, and in evaporation the product obtained is mostly a liquid, whereas on the other hand for drying it is actually a solid. Mostly for drying we consider only solid material. So in evaporation the heat source normally used is steam, whereas in the process of drying the heat source or the medium we use hot air or hot gas to achieve this process. So one such examples of drying include tray dryers, rotary dryers, vacuum dryers. We use different kinds of heat source. So basically it is important to understand that both heat and mass transfer are involved in this process of evaporation and drying, but however evaporation largely falls into heat transfer and drying largely falls into mass transfer. Next, we are going to look into the effect of properties of solution on evaporation. It is important to know the properties of the solution that I normally take for this process of evaporation. For example, let us imagine I have a solution which could foam a lot, which means when I start to heat, it just foams and then comes out of my evaporator or whatever the pot or like a vessel I have. Then there's no point in using this kind of a solution for this process. I have to go for some specialized process, right? So it is important some certain properties of the solution to be checked before we are taking for this process of evaporation. So first property is concentration. We should check this very importantly, because if I have a very dilute solution, then imagine I have to remove excess amount of the solvent, right? Then it is going to cost me a high amount of energy, so the process will not be efficient at all. Instead I can buy a solute and the solvent and I can put it together to come to the concentration which already I need. So there is no point in going for evaporation operation with a very dilute solution. So the concentration of the solution needs to be checked first. So the second one is foaming, which I explained before. The solution that I take for the process of evaporation should be less foaming. The third one is scale. Obviously, when a solution which I take for the process of evaporation has the tendency to scale a lot, which means if it could cause dirt and foul to my evaporator, obviously the heat transfer rate is going to disturb. And when the heat transfer rate is going to be disturbed, the overall process will not be very efficient. So less scale and less foaming liquid should be suggested for this process of evaporation. Our next one is temperature sensitivity. Since this process of evaporation is going to involve at to the boiling point of the solution, we should make sure whatever the solution that we take for this process should not be sensitive to temperature. Okay. Next one is corrosiveness. Obviously when it's going to corrode my evaporator, then I have to put in a lot of amount, then the operating cost, initial cost, everything is going to cost me very higher and huge, right? So and these are the properties of solution that should be avoided when we go for this evaporation operation. Particularly we should avoid scaling, foaming, temperature sensitive, very dilute solutions and corrosive solutions. So next we are going to discuss about one of the very important concepts of evaporator, that is capacity and economy of an evaporator. So any evaporator is actually evaluated in terms of this capacity and economy. It starts with capacity. So capacity is the kilogram of water evaporator per hour. For example, imagine I have some 60 kilogram of solution in which I have nearly 40 kilogram of water. Okay, so in 1 hour how many kilogram of water can I evaporate from this solution is called as capacity of an evaporator. Okay, so basically it is kilogram of water evaporated per hour. On the other hand, economy of an evaporator is kilogram of water evaporator per kilogram of steam fed. So economy basically connects between the input and output. So as we discussed before, economy is about the steam that is being fed. The heat source for the evaporator is actually the steam. So what is the amount of steam I am feeding into the evaporator? And for that, what is my output? The output is the solvent that is being evaporated. For that, how much amount of water is being evaporated? So kilogram of water evaporator per kilogram of steam fed is normally called as economy of an evaporator. It should be noted that for a single effect evaporator, the economy is always less than 1. So in order to improve the economy of an evaporator, we normally go for more than one effect, which means we have a single effect evaporator followed by another evaporator followed by another evaporator. So when we have more than one evaporator setups, we normally call it as a multiple effect evaporator. So each will be called as effect. For example, when we have more than one effect evaporator, what happens is that the input to the first evaporator will be steam. Obviously, some amount of vapor is going to come out of my first evaporator, right? So this vapor, I do not want to waste it. This is nearly equal to that of my steam. It also has all the amount of heat energy as just like my steam. So I do not want to waste that vapor. So this vapor will be taken and sent into the next effect, right? So here the water that is being evaporated, that is converted into vapor, it also has very good amount of heat. That heat is being used to heat the fluid or the solution in the second effect, right? Again, the second effect is going to give off some vapors which will be sent to the third effect. In this case, my input is going to remain the same. I am feeding into the evaporator only 1 kilogram of steam, but I am going to evaporate a lot of amount of solvent, right? So this is the importance of having a multiple effect evaporator. So if I want to improve the economy of an evaporator, obviously I can go for multiple effect evaporator. So in the next slide we are going to look into what are the ways of improving economy of an evaporator. So as we just discussed, if we want to increase the economy, first step is to go for a multiple effect evaporator. On the other hand, we can also go for a system called vapor recompression. For example, imagine you have a single effect evaporator. You're feeding into the evaporator 1 kilogram of steam. Okay, this 1 kilogram of steam is taken up by the solution and it is evaporating some half kilogram of vapor. Okay, this vapor can be collected back and it can be recompressed. Once it is recompressed, what happens is that the more amount of heat energy will be sent back to the vapor, and this heat vapor, it can be recompressed and it can be sent back into the same evaporator. In this way, it's like more than like recirculating the same steam into my evaporator. In this case also, my input remains the same and the input is used multiple times within the same evaporator, that is in the single effect evaporator. This is also one of the means by which I can improve the economy of my evaporator. So if I want to improve economy, either I can go for a multiple effect evaporator or I can go for vapor recompression systems. Next one, please look into the image. You can have the images of a single effect evaporator and a multiple effect evaporator. You can see that the feed is sent into the evaporator from the bottom and the steam is sent into the evaporator from the steam chest at the top. So what happens, you have the solution inside the evaporator, and once this heat source is being sent, the solution will be heated to its boiling point and the water will be converted into vapor. The vapor here, you have only one vapor in case of a single effect evaporator. On the other hand, please compare it with that of a multiple effect evaporator, where the vapor that is coming out of the first effect is being sent into the steam chest of second effect, and the vapor that is coming out of the second effect is being sent into the steam chest of the third effect. So it is important to know that the vapor, it is being reutilized in case of a multiple effect evaporator. So here you can have a clear distinction between a single effect evaporator and a multiple effect evaporator. This is one of the means in which I can improve economy of my evaporator. So next, so whenever we speak about evaporation, flash evaporation is also a very important concept. Imagine I have a feed solution which is actually at a temperature higher than the boiling point corresponding to the pressure in the vapor space. For example, imagine the evaporator will be always kept at a particular pressure. Why? Because you know that the boiling point of water is 100 degrees Celsius only at 1 atm. So when the pressure is going to increase, obviously the boiling point is also going to increase, right? So in this case, when the evaporator is maintained at a different pressure, and for that particular pressure, the boiling point of the solution is actually higher. In such case, when this feed at a higher boiling point gets inside this evaporator at a maintained at a lower pressure, what happens is that it just flashes. The feed just flashes as soon as it enters into the evaporator. In this case, the solute just gets down, whereas the water vapor will be just flash and converted into vapor as soon as it enters into the evaporator. The same flash evaporation principle is also used in equipments like spray dryer, one of the very important equipment where mainly used for producing tender coconut powders, milk powders. It has multiple uses by making use of this concept of flash evaporation. So it is important to understand this concept because of its difference in the boiling point of the solution and of the pressure that is maintained in the evaporator. So the next concept is boiling point elevation. So normally you know that the boiling point of water is going to vary when the pressure actually increases, obviously. So imagine I have two containers, out of which one I have filled some 100 ml of water, and in another container I'm taking 100 ml of water and adding one teaspoon of salt. Okay, so in one side I have a pure solvent, on the other hand I have a solution because it contains solute, sodium chloride, and solvent, that is water, and both at normal atmospheric pressure. If I'm going to heat it, the boiling point of water will be 100 degrees Celsius. But what happens to the solution? Its boiling point is obviously going to increase, right? So this difference is called as boiling point elevation or boiling point rise. So the difference in the boiling point of pure water and that of a solution is normally called as boiling point elevation or boiling point rise. So based on this, Duhring conducted a number of experiments and come up with a rule called Duhring's rule. He says that the boiling point of any given solution is actually going to vary linearly to that of boiling point of water. He conducted a lot of experiments using pure water as a solvent, as a pure water, and solutions by using different solvents, okay, and also the solute. So he found out that you take any solute, the boiling point of the solution is going to vary linearly to that of boiling point of water. This was the conclusion he came up with. So with this conclusion, he called as Duhring's rule. So this is basically about boiling point elevation and Duhring's rule. So in this lecture, we discussed about what is evaporation, what is the importance of evaporation in heat transfer operation when compared to that of drying. So what is how this evaporator is normally evaluated, for example by making use of capacity and economy concepts, and also methods of improving the economy of the evaporator by using multiple effective operators, and also this concept of vapor recompression systems. We had a clear cut idea about single and multiple effective operators. Then we moved on to this boiling point elevation and Duhring's rule concept. So in next video I would like to come up with more important concepts related to heat transfer. Until then, keep watching. Thank you.